Hello. So for today, I want you to mostly focus on the Unit 2 quiz on probability. Um, but I wanted to give you a very short worksheet starting the next unit on statistics and data. The topic of this worksheet is about correlation. So let's jump right to it. Okay, so what is correlation? So correlation is the relationship between two different types of variables or data, where knowing one thing about a variable gives you some information about the other. For example, if you recorded people's body weight and body height, they will usually be positively correlated, which means you might have, if you plot people's weight versus height, sorry, excuse my handwriting there, um, then people who weigh more tend to be taller people, and people who tend to weigh less tends to be shorter people. And that's not a perfect relationship, but you get some information about the other by looking at data of one of the variables, for example. And this could be useful because one of the variables might be much easier to measure or uh, much, much cheaper to measure, or maybe it takes less effort or time versus the other variable, which might be difficult to get or expensive to collect, might be more important to us. So these are type of relationships that we look for in any kind of science or social science or lots of different disciplines. So when they tend to be higher together or smaller together, we say they are positively correlated. Even if the relationship is reversed, where maybe we're looking at the age of car versus selling price of a used car, maybe. So older car might be selling for cheaper amount of money. So that could be a negative correlation, but you still get information about the other variable. So even if the relationship is reversed, we say they're correlated. We just say they are negatively correlated. If knowing about one variable doesn't give you information about the other, we say there's no correlation, there's no fixed pattern between the two. Okay, so correlation is a useful concept, but it is often abused and misunderstood. And it comes from the fact that I think being able to be useful for prediction doesn't necessarily mean they cause the other to happen, but it's often misunderstood to be. So the big takeaway before you're done with this video is to know that correlation is not the same thing as causation. My favorite example to demonstrate this idea is about the two variables, hand size versus spelling test scores. So if you record people's like a hand size, so maybe the measurement between the base of your palm to the tip of your middle finger maybe, and give them also spelling tests and record their scores, they tend to get some positive correlation, small correlation, but there is some correlation. Can you think of a reason why that might be true? So believe it or not, it is true that they are positively correlated, but it's not the hand size that's causing the person to be a better speller. It has more to do with their age. So older people or like adults tend to be a little bit better at spelling than a very young child with small hand size. So this is a situation where there's a third hidden variable that's explaining that the two variables to be correlated. But you can see that the hand size is not causing you to be better at spelling or vice versa. Like being better at spelling doesn't give you larger hands. I hope that's obvious. But even when it seems obvious in this example, it is often extrapolated. If something are correlated, people tend to assume that one is causing the other, which is unfortunate. So the rest of the worksheet is kind of drilling down on this concept. So there's an example of ice cream sales versus drowning deaths. So I want you to kind of think about why they might be correlated, but why is it not the causation? In the backside of this worksheet, I've gotten graphs from superiorscorrelations.com. So they give you lots of different data. So they collect lots of data and put out some graphs that suggest that things are correlated. But in this case, there's absolutely no relationships whatsoever. It's just coincidence that they're related. And what I want you to do with these graphs is that just come up with, it doesn't have to be real, like a silly reason why one might cause the other. So I want you to try that. This part is not serious. Just share it with me, and I want to be amused. And actually, this type of thinking is related to a logical fallacy that you've learned in the past from the Bad Arguments book. So I want you to go back and find what this logical fallacy is called, okay? And just tell me why that's this type of logical fallacy. Anyways, that's it for this worksheet. I want you to focus on the unit quiz, and I will see you next week.